All right, good afternoon, class. Mr. Wheeler, a former teacher of mine, is our special guest today, and we are starting Unit 6 today on linear functions. And we'll need you to get your textbooks open to this page, so I'll just pause for a second and wait for you to get those out. Crystal, no, you can't go to your locker to get your book. Holly, take those earphones out of your ears, pay attention. Tyler, no, you can't leave early today. Cameron, he's probably locked outside the room. He's probably 5 minutes late. Okay, welcome back, class. All right, we are going to work on this unit on linear functions, and the concepts we're going to build on are some of the work that we did in grade 9 with graphing lines. Linear relations is a mathematical term for graphing of lines. We're going to recognize properties of lines, linear relations more specifically, and we're going to solve linear equations. Some of the big ideas you can read on your own to the left margin, and also recognize that the terms in this new vocabulary will be defined at some point during this unit. Today you're going to learn about the 3 terms, specifically being slope, rise, and run. Okay. So that being said, we'll turn to our first page here, which deals with 6.1, the slope of a line. So let's look at this together. Slope of a line. We're going to make a connection. Here you see a slide, and I'll make this a little bit bigger. This is the town of Fallher in Alberta, and it's known as the Capitale de Miel du Canada. And the honey capital of Canada, more specifically. It has a 3-story slide in the photo. What we want to know today is exactly how steep is this slide? Well, we're needing to come up with a measure of steepness, more specifically. So what we're going to have you do is try this activity. With a partner, you're going to work with the grid provided, and you're going to answer questions A through C, cross out D, and do E and F. So with me now, just cross off this question D. Okay, so give that a shot, answer those questions in point form, and in 5 minutes or so, Mr. Wheeler will go over your results. Okay, welcome back. Mr. Wheeler, press pause if you haven't given him enough time. Okay, thank you. Welcome back. Let's see what you and your partner came up with. Part A, you were to think of a strategy to calculate the number which would represent the steepness of these lines. So to answer that, I'll kind of defer to question B. It says, which is the steepest line segment? Well, everybody, I'm thinking, can tell that by looking at this diagram that going from B to C, if they had a protractor, would represent the steepest line. So because I have this fancy smartboard, I'm going to put this protractor up on the screen and move it over here. And as you can see, that line from B to C on my protractor is about a little less than 70 degrees. D to E is more like around 62 degrees. And those being the 2 steepest lines, definitely the protractor shows me that BC is the steepest. But you won't always have a protractor to do that type of work. So we're going to need to find another way. A second way to find steepness would be by comparing how far you go up to how far you go over. Okay, so let's look at this line BC, which we already know is the steepest. How far we went up? Well, we went up of a 1, 2, 3, 4 boxes to get from the bottom to the top. And then, after we rose up 4 boxes, we went horizontally over 2 boxes. So we would say that we've risen or rose 4, and then we ran 2. Compare that to the second steepest line. The second steepest line we said was D to E. So here we went up 3 and then we went over 2. So let's write that in here. We went up 3, and then we went over 2. Well, notice that a rise of 4 and a run of 2 is greater than a rise of 3 and a run of 2. So it says, which is the steepest line segment? How does your number show that? Well, my number shows that I've gone up more than what I went up over here, and it also shows I ran the same. So, part C, which is the least steep? Well, least steep would be the line that has no slope, which would be this line over here from A to B. How does its number compare with the other numbers? Well, this line doesn't have a rise. It just has a run. 1, 2, 3, 4, 5, 6. So we'd say that there's no rise, which is 0, and then there's a run, or just a move over by 1, 2, 3, 4, 5, 6. So I'll put 6 here. So it definitely is the least steep. Part E, how are line segments CD and EF alike or different? Well, CD, let's compare its steepness. Let's look at it. It goes up 2 this way and over 1, 2, 3, 4 this way. EF goes up 2 this way and over 1, 2, 3, 4, 5 this way. So how are they alike? Well, they're alike because they both go up 2 and over 5. Up 2 and over 5. How are they different? Well, they're different because CD goes up to the right. EF goes up to the left. They go in a different direction, even though their steepness appears to be the same. They both are up 2 over 5, but one goes to the right and one goes to the left. How do the numbers for their steepness compare? Well, we just said they're the same steepness. Part F. What number would we use to describe the steepness of the horizontal line? Well, the steepness of the horizontal line would be, as we said, no rise and a run. So it has a measure of 0 steepness because there is no steepness to it. It's flat. So compare those responses to what you had, just to look for a general understanding. We'll move more specifically into how math will be used in first example. Thanks for listening, and continue on to check for understanding number 1.